Okay ladies, a quick look at stratified sampling. So I've set out a basic table with the year groups across the top, 7, 8, 9 and 10, and I've assumed, clearly unrealistically, that there's exactly the same number of students in each year group. This gives me a total across the 4 year groups of 400. Now, what stratified sampling means is making sure that your sample reflects accurately the population that you're sampling from. Now in this case it's nice and easy, but I think it's useful just to help you to understand how it works. So if, for example, I wanted a sample size of 40, I want to make sure that I select appropriately from my individual year groups the same number of students. Hopefully you can easily see that this 40 I would take, because I've got 100 in each year group, I can afford to take, or the right thing to do rather, would be to take the same number of students from each year group. So I would simply take 10 from year 7, 10 from year 8, 10 from year 9, 10 from year 10, and that would give me my sample size of 40. It's all in equal proportion because I've got the same number of students in each year group. Okay, let's now look at a slightly different example where the population in each year group is slightly different. So this time I've got a total number of pupils of 460 and I have got a different number of pupils within each year group. And let's say I wanted my sample size this time to be, let's say I wanted it to be 60 pupils. So what I need to do is make sure that I get the right representation or the right proportion from each of these different year groups such that it reflects the number of students in each year group. So in order to do this, what I'm going to do is I'm going to do 60 divided by my total population of 460, and I'm going to do that on my calculator. So 60 divided by 460 gives me 0.13043. And effectively what this means is that I'm wanting 13%, yeah, we know that as a decimal, 0.13 is 13%, so that's the equivalent of 13%. So I'm sampling 13% of my total population in my sample. So I want to make sure that I get 13% of 100, 13% of 120, 13% of 110, and 13% of 130. So all I need to do is have 0.13043, so I'll keep that in my calculator. For year 7, I'm going to times it by 100. For year 8, I'm going to times it by 120. For year 9, I'm going to times it by, just move that up a little bit, or maybe make the screen a bit bigger. Okay. Sorry, just moving the camera. For year 9, I'm going to times it by 110, and for year 10, I'm going to times it by 130. So I'm going to put all of those numbers in my calculator. So 0.13043 times 100, well, we can do that quite easily, it's going to be 13. 0.13043 times 120. It's going to give me 15.65. 0.13043 times 110 is going to give me 14.347. And last but not least, 0.13043 times 130 is going to give me 16.9559. Obviously, I can't have 0.65 of a person, so I'm going to need to do a little bit of rounding here. So I'm going to select, say, 13 from my year 7s. I'm going to round this one up to 16 from my year 8s. This one's going to be 14 from my year 9s. And last but not least, I'm going to round this to 17 from my year 10s. I now need to add this little lot up. So I've got 13 plus 16 plus 14 plus 17. Gives me 60, which is good because that was the sample size that I originally wanted, and that's how I'm going to allocate my students. So my stratified sample size would be 13, 16, 14 and 17, and that comes to 60. Just bear in mind that you might need to do a little bit of rounding up and down here because you definitely want your sample size to come up to 60, not 59 and not 61. Okay, so hopefully that helps you to understand how we do stratified sampling.